All right.
Okay. Well, again, my name is Bryon Gloden, and thank you for inviting me here to be able to share with you some things that I've learned over the last couple of years on Java security. And by all means, I want this to be kind of an open dialogue. So, if you have questions throughout the presentation, don't hesitate to just ask a question. I mean, you don't even have to raise your hand. You can just we'll just have a little conversation here. So
we're not shy.
What's that?
We're not shy.
We're not shy. Oh, that's good. Yeah. I remember him saying, he said, not at all. He said, expect some good questions. So I'm looking forward to it. Because we are a little late here starting, apologize about the pizza being here a little bit late, but I'm going to try to get through this briefly. I think it should be about 45 minutes worth of talking here, and we'll save some time for question and answers. So before I jump into this, though, just out of curiosity, for my own sake here, how many people in the audience here have been developers, Java developers, for less than a year? Right? Okay. George can raise his hand there, because George is my sales guy, and I know less than a year. Okay, 2 years? 3 years? 4? 5? 5?
Some of us have been coming to this meeting since '97.
More than 10. Okay. More than 15. Good. So.
Wait, Java
developers, yeah. How old is this language?
James Gosling in the room.
In it before it was released, yes.
Okay. All right. Well, hopefully those people that are more familiar with Java, hopefully you can take something away from this presentation. So, who am I and what is this company that I work for called Arxan? We're a software company that was started out of some research done at Purdue University. Any Boilermakers in here? All right.
I'm actually doing a master's program right now. So.
Excellent. So I'm also a Purdue grad, computer science there. Go Boilers. And so that's where our company started anyway, out of some research out of the Center for Education and Research and Information Assurance and Security, otherwise known as SERIAS. We've been serving government defense markets for a while with our software solutions, and for the last few years have kind of moved in more to commercial work. So we're a private company, startup, kind of an old startup, right, 1998, but we're still doing well. We've got a couple different offices. We've got a headquarters in D.C., Bethesda, Maryland. We've got a research group in West Lafayette, Indiana. And then we've got engineering out of San Francisco in the Bay Area, which is where I'm from and also where George is from. So at the end of the day, what we're helping customers do is essentially protect the intellectual property that they have inside their code. And we'll get into what all that means. We're also helping to protect different code modules from tampering and reverse engineering. And we'll get into some of that too. And then briefly about myself, again, Purdue grad. I've been with Arxan for about 5 years now, computer science. Was doing consulting for a while, was doing some work basically as a hacker, and then kind of transitioned into more of a pre-sales role. So I get to talk with customers about their security problems every day, and hopefully help them solve those problems. Any questions at this point? Okay. So what are Java security threats? There's lots of different things out there. I want to kind of narrow the scope for today's talking point. At a high level, these are some of the categories, if you will, of different attacks. You have spoofing attacks. By the way, Stride is a classification system by OWASP. But you have these are the different problems. Spoofing, essentially different applets. How can you trust that an applet's from a publisher that is releasing these different modules? Recently, I was on iGoogle. If you guys are familiar with kind of the portal iGoogle, and you can install these little widgets on your page. It's really nice. Well, the other day I was searching for the E-Trade widget, and typed in E-Trade, and I found three widgets that were available. I'm guessing 2 of those probably weren't the real E-Trade widgets. But they all look the same, right? You put them on your iGoogle page, they ask you for username and password, and it's game over if you pick the wrong one. It's kind of like, choose under which shell. It's kind of the shell game there. Some examples of spoofing. I mean, that's an emerging problem. Also, another category of attacks is repudiation. So this is essentially, if you do a transaction, how can you hold somebody liable for that transaction? They claim they didn't do it, yet you seem to have some evidence that they did. So it's kind of an authentication problem in a way. Denial of service. You see these a lot in the news. I mean, eBay's been taken offline, Amazon's been taken offline with this. A number of different companies have been taken off. Essentially, denial of service is where you flood the network with so much traffic that legitimate users aren't able to access a particular web page or site. This has kind of grown into this new problem, which is distributed denial of service. Essentially, all of these computers that are vulnerable to different attacks have been taken over, and they're zombie machines now, if you will. I like to think of this as the problem that my mom has, maybe, and my grandma has. They always ask, well, I don't really care if somebody hacks my computer. I mean, what do I have on there? I don't do anything. Well, the point is, your computer can become a zombie, and there's basically someone that's operating that zombie, and then they want to take down a site. They're going to activate your computer, and they're going to send packets, network packets, from your computer, along with the other million computers that they own. Own being the hacker term, OWN. Elevation of privilege. I mean, this is classic. Get system level access. How can you go from user land to basically kernel land? And then finally, the last 2, tampering and reverse engineering. So these are what I'm going to focus on in this presentation. Tampering, essentially going in there, modifying bytecode, changing values in memory, both while the application's running, and then also changing code when the application's resting on disk, so that when it does run, it executes a different set of logic that wasn't programmed in there, but maybe added afterwards or taken out. Common examples of tampering attacks. Anyone have an example of perhaps an attack where tampering's been leveraged? Come to mind? DRM, I think of a lot of times. Defeating DRM systems. You can get in there and you can change some of the logic. And then also reverse engineering. So, just based on the level of expertise here, I'm sure people are familiar with tools like JAD, perhaps, which is a decompilation tool for Java. So essentially going from bytecode, so you compile, you link, and then you've got this bytecode, and then essentially with decompilation, you can go and you can abstract that back to source code by looking at metadata and things like that. So you're able to look inside the code, find intellectual property, find secrets inside the code, and then hopefully launch an attack. Well, hopefully if you were an attacker, but hopefully not. So I think the important thing here is what I'm not focusing on today are things like input validation attacks or SQL injections or cross-site scripting or these things are popular today. The problems that we solve, I mean, it's kind of a constant, but there are some other attacks that really need to be solved first, and then you can focus on tampering or reverse engineering. Most attacks, at least that I've been contracted to work on, have really started with reverse engineering, understanding logic, and then kind of moving up the stack. So why even evangelize? I mean, why even get out in front of a real technical audience like you guys and make the case for Java security? Just a couple of reasons here. Lots of emerging markets outside the United States are looking to kind of get into the software game, if you will. And one of the easiest ways to do that is to just look at existing products out there to kind of steal what they've done and resell it or remarket this. And so you're seeing this in a lot of developing nations. If you look at some reports from the BSA, for example, it's a staggering amount of companies that are involved in piracy. Not just stealing legitimate applications like whereas, things like that, but also going and actually stealing the code and re-implementing it and trying to resell that code. An example of this that with the company I've worked with firsthand was they had a sales department in China that was selling their products, and they ran into a situation where a competitive situation where they're competing against another company operating under a different name, but it was actually the same product. What they had done is gone in there and changed some of the strings, changed the splash screen, and of course cut the price by like about 90%. So they were competing against their own product. And this is a kind of a reoccurring problem, at least an emerging one. Intellectual property, 15 years ago, patents, IP used to be tangible assets. These days, something like 70% of intellectual property is non-tangible now. It's inside code. So if you can get to those secrets, if you can steal those secrets, then there are people that are going to try to do that. Also, the attacks that we've kind of seen in the last, at least from a security perspective, have been moving up the stack. And what that means essentially is, they used to be problems that were on the network level. So then we created firewalls, right? And then they kind of moved up to the operating system, and then we started adding antivirus systems to the operating system. And now they've kind of moved up to the application level, if you will. So it's really the application now that's kind of the new frontier for a lot of these attacks. And then, of course, Java itself is just, with all the metadata that's inside there, it's it makes it very easy to kind of look inside there and do some of this reverse engineering. A lot of these data values and things inside code are all inside there. And so, some of these portable languages like .NET and Java now, it's just made it that much easier to kind of reverse engineer and tamper and do these attacks. If you think of like writing code with native languages like C, the best that you can do, well, you can disassemble, essentially abstract from binary to an assembly language. And there are some tools like hex arrays that attempt to allow you to abstract to source code again, but it's a very difficult problem. But at least with these managed languages, you can just decompile right away and you can look at source code. So the point is, it's become easier. Lots of exciting things happening. So we're like Java FX. You want to hear a program with Java FX? With Ajax? A couple Ajax people. Flash. Want to do Flash development? Kind of these scripting languages. Very rich feature set, but also increased risk of vulnerabilities. And then also, this idea of these, the platform. So this was the Google example I gave you before. Google being the platform that you can put the widgets in. Facebook being a platform that you can put applets or different apps inside. Apple, the iTunes store. All these things, it's the platforms being abstracted up to a higher level, and really security isn't something that's being thought of and built into that. You're seeing a trend moving towards adding security, but right now it's kind of the wild, wild west out there. So, for the people in the audience here that actually do web development with Java, just out of curiosity, how many people are creating kind of the applets, the web applets versus the standalone native applications? Like I think of Eclipse as kind of a standalone Java application, and I think of applets and widgets being kind of the server applets. So people in here doing the standalone kind of Java development. Okay. 2, people doing the other type of development, more applets or server-based.
Right now.
So when you say server-based, you mean just they're served up at the server, right? But when they're ran on the client.
Run on the client,
Yeah.
yep. But kind of that client-server model. There's network that's inside,
Yeah.
if you will. Okay. So maybe not surprisingly, there's less people in here that are doing native development, more people doing kind of the client-server development, and that's the trend. So, whether you're doing the native application or whether you're doing the client-server application, there's vulnerabilities in both places, and that's the point of the first slides here. First couple bullet points, rather. Over $1 trillion lost in this intellectual property theft. It is a serious problem. And again, just more data on this: 75% of hacks occur at the application level. So let's get into more of the vulnerabilities here. So has anyone ever decompiled? Just out of curiosity, anyone decompiled? Okay. So you're all hackers?
Yeah.
Is it fair to say that?
There's tools you use in the IDE is to show you the code, but you don't have the source.
Yep. So is all reverse engineering evil then?
No, thank God for that.
Yeah. And they'll do a lot of stuff.
What are some cases where you would want to reverse engineer?
Debugging platform your software runs it.
Debugging platforms? Platform code?
Figuring out what the corner cases are in the library.
Looking at corner cases. Legacy code. Maybe anyone had been given an application that you have to support, and you don't really have source code there.
Poorly documented commercial code.
What's that?
Poorly documented commercial code. Poorly documented commercial code.
Okay.
To debug into something
Debug. Do debugging.
that you don't have the source to.
Does anyone decompile something, checked it in, and then that becomes your code base?
You're asking me?
I'm just wondering out of curiosity.
Yeah.
Probably
I have seen cases where people will decompile, actually make changes to code and then recompile and check in. And, they can remove features. Reverse engineering is another way of adding features to this, to legacy products if you want to update it. Anyone familiar with the DMCA Act? Basically the digital rights, digital media.
Millennial do it in copyright.
Millennium Copyright Act.
That's right. It's in all the EULAs that you get for software. You may not reverse engineer or tamper or modify with this program. In some cases, though, you can for interoperability. So again, another reason why you want to be able to do reverse engineering. I'm not making a case for hacking. I'm just saying, there is two sides to this coin. Security is about preventing these. In some cases, you actually need to do these things. So I think we've covered reverse engineering there. With tampering, again, I gave a couple examples of this. Something else that is occurring now is people are taking these open source applications, or even if source code is not available, they're taking the jar files and they're basically decompiling them, and they're adding malicious code inside there, malware, if you will. And they're distributing those applications on free sites, shareware sites. So people are downloading these things, and they're running code, inside their enterprise or inside their trusted networks, and now it's got all this malicious code inside there. It's an example of a tampering attack where you've added new stuff to it. In the traditional case, though, tampering is really just as easy as going in there and modifying some of the bytecode. If you have a license management system, for example, check for license file, if expiration date is so and so, then do not allow you to run the software. You can go. That's just an if statement, right? We're developers. Typically, that's just one if statement, right? So you go in there and you remove that if statement and you recompile that code, and now you can use your program for free. Don't do that. I'm just saying that's an example of that.
Thanks for that.
Yeah. Key and credentials. Unfortunately, I've been guilty of this before. Hard-coded username, password into an application just because it was the easiest thing to do at the time, and I had a deadline I had to make, so I did it. It wasn't really until I found out how easy it is to kind of discover that information that I go, oh no, that's a bad idea. key information. You know, if you're doing things with like OpenSSL, for example, and you have private keys, a lot of times you'll see that key information actually added to your application, or just embedded in there statically. Again, if you can go in there and you can find that data, you can essentially break trust. You can spoof applications. Does that make sense? Okay. And then finally, I mentioned JAD as an example of a decompilation tool. There are others out there. Anyone have a favorite decompilation tool they like for Java? There are many free examples of decompilation tools there, simply because it is kind of an easy thing to do. So I mean, it's something you could do at a basically like a college development level. You can create these decompilation tools. So tons of easy access to these tools means that lots of people are actually going in there and doing this, which makes the problem that much worse. So just want to give some examples at this point of more hacking examples. Before I dive into this, though, is there anyone in the audience that would like to share a particular example of, where they've kind of seen or heard or read about any attacks that leverage reverse engineering or tampering here? No one. Security is just not. Is this something that you guys think about when you're doing development? I mean, do you think about the code that you need to protect in there, and the secrets and things like that? Some people, maybe not.
The company I work for does. They think that obfuscation is a brilliant thing, and they send off the jar files all obfuscated all the time.
They do.
Causes no end of headache for the testers, but
Yeah. Is that because what is the driving reason behind that? Why do
they
they?
thought it was a good idea.
Yes, that was a good idea. It is a good idea.
I just think no positive to that.
It's a great idea as long as your product has no bugs in it.
Right.
They are.
Or as long as you have robust support and all that stuff. But yeah, it does slow down the development life cycle. I've had to deal with that too. Third-party library, it's obfuscated, it's licensed, and anytime we get a stack trace or anything like that, we get a call up support and say, hey, this is what we got. Get back to us the next day or something. So.
Yeah. And that's a really good point. I mean, you add these kind of anti-tamper, anti-reverse engineering techniques to it, and then it makes debugging a little bit more challenging. I'll talk to specifically some examples that make debugging really challenging, but that's kind of the cost of security, right? Fortunately, if you choose the right solution, you can develop and not have to be obstructed by these things, and then only at the point you're ready to release code is when you add these security controls to it. Still, when you want to do post-mortem debugging, you still have to deal with these things that you've added, but at least you don't have to deal with them during development. So, in this first example here, exploits enable theft of sensitive data from backend databases. This is really an example of a client-server application. So, as the perimeter extends, like lots of enterprise companies that a few years ago at least used to have all the code, the logic on the server side. The client was just a browser, kind of a dumb browser, and all the data was behind the firewall, behind the server, and was basically only the server applications could get to it. Well, what you're seeing now is kind of the clients becoming more powerful. The applets, the widgets. There's a couple reasons why it makes sense to kind of push out this this code, if you will, to the edge. The example that I'm most familiar with is basically it's just for performance reasons, right? If you're doing all this on the server side, it doesn't scale as well. If you can kind of push that problem out to the endpoints and let each of the endpoints do a little bit of it, you can do load balancing a little bit easier that way. I'm sure there's probably other reasons too, but that's just the one I'm most familiar with. So, just drilling down on this, though, this first bullet point, there are cases where that client code, the applet code that you're using, again, it may have usernames in it, it may have passwords, it may have keys, credentials, things like that. If you can go in there and you can muck with that, essentially what you're doing is you've got a backdoor into the server. And at the end of the day, if you can get past that server and you can get to the data, you're able to do attacks that enable you to steal things like credit card information or social security numbers, things like that. Again, not that I'm advocating for any of this at all, but I'm just saying this is something that you can do.
You're saying if that data is actually down on the client.
I'm saying if that data is actually on the server, if that data is behind the firewall in a database, and the clients trust it. I mean, that's really what this is at the end of the day. The clients trust it, right? So if you can go in there and you can muck with that code and change it, and so that client now does something you want it to, then when that client connects to the server to get the data, everything from the enterprise's perspective is they're looking at the application, they're going, oh, this is our app, we trust this, all right, you've got access, run this SQL query and extract this data. Well, what if you've gone in the application and you've actually changed that SQL query in the client, and now you've been able to enumerate data that you should. Does that make sense? Okay. Desktop applications, again, this is more the standalone. The example I use here is Eclipse, because that's probably the best example I know of, at least, where it's just a standalone application. You can put malware inside there. You can redistribute that. Think about how many people use Eclipse. Imagine if you could just put a little bit of malicious code inside there to do something. This is like the Office Space example, where they just kind of shave a few cents of a penny off of every transaction, and over time it adds up. You could do something like that, perhaps, but injecting malware into these applications. And then finally, the classic case of just licensed software. Anything that's got like shareware, license management on it. There are some secure systems out there. Not everything can be broken, but I think if you're a developer, you probably have seen cases of piracy, or that it's easy to go in there and kind of change things around, create counterfeit licenses, over-license, if you will, in some cases. So circuit-bitting license management is just made that much easier now with languages like Java and .NET. So hopefully you understand kind of the problem. Let's kind of switch gears a little bit and talk about some of the solutions out there. To address reverse engineering, obfuscation was mentioned as a solution, also known as kind of code transformations. What you're trying to do here is break these decompilation tools. These tools are only as good as what they expect to be looking at. Try to explain that in a different way. Sometimes there's constructs in code that as you go through compilation and linking, that output, that bytecode's expected to look a certain way. And these tools that do this decompilation, they expect that format to be there. They expect those code constructs to be there. An example of an obfuscation technique that would break some of these decompilation tools is like a to-do, for example. You can add that in bytecode, but very rarely will you ever see a compiler actually generate that bytecode for you. If you program that at a high level and then you run it through a compiler, you won't typically see that particular instruction. So if you can go in there and you can add that instruction manually at a bytecode level, then these tools that are trying to do this decompilation, they'll look at that and they won't necessarily know how to create the source code around that code construct. Does that make sense?
Just out of curiosity, how do the tools that are supposed to be able to read the bytecode handle that?
Pardon me?
How do the tools that are supposed to be able to understand the instructions?
The JRE, for example.
Right. How do they understand it when you do that?
Well, they're operating at that. Remember, they're at that bytecode level. So I mean, it's a valid keyword.
Right, so why wouldn't the decompilers be able to do the same thing?
Yeah.
Why are they so easily
Yeah, it's the challenge is, you know, extracting that representation of bytecode back into something meaningful at a source code level. And you know, I'm not saying that there isn't a tool out there that could do that. I'm just saying that's that level of sophistication that's probably beyond what, you know, college student is going to be able to do with their decompiler. So
I believe you could generate loops in bytecode that are never generated by any of the compilers, for example. So any of the compilers look at it and say, all I can do is make some jumps and ifs out of that. I don't really understand what the original high level was. And it might come out looking really funny or something. At least I understand there's some ways that just...
Yep.
Now with your other steps, it becomes more and more unreadable as the steps are added. So
Yep.
if
Yep.
you've taken away the high levels constructs, you're left with staring at simple breaks. And,
But if you add all that stuff, do you still have working code?
you do. I mean,
yeah, that's the trick, isn't it?
that's the trick.
That's what you
It's
pay it for.
create this code that the JRE can run,
Yeah.
right? But to do it in a way that breaks these decompilation tools.
Okay.
You know, it's not even so much that you're just trying to break them. It's just that you're trying to make the code, the source code that they produce, so unreadable that it's, you know,
Not worth it.
that's not worth it, right?
You can look at obfuscated code, but it
Yeah.
doesn't make any sense.
Yeah, you can look at obfuscated
Yeah.
code, but it's going to take you just as long to understand it
A lot
as.
of code we developed.
Are there tools out there that also obfuscate without, you know, pre-compiling, right? They're pre-compiling obfuscators that just basically take all your variables and make them one character variables.
Yeah, exactly.
Yeah.
Yep.
Right.
Yep.
That's what most of them do.
Yeah.
Yep. So it's a good point. It's a good question. Essentially, is what phase do you apply obfuscation? You can apply it to your source code, or you can apply it post-link, post-compilation. You can do it in either phase. And there's advantages and disadvantages to both of those. Some other examples of code transformation here. You can do instruction substitution. So, you know, if you had like an add 3, you can do instead an add 5, subtract 2. Why would you do this? A couple different reasons. One, you're trying to make that code more difficult for somebody to read and understand. I mean, they're looking at this going, why are you doing this? If they look at my code, they'd probably actually see that in there, and that's just that's not on purpose.
Just how I code.
It's just how I code.
You can
Is it
hide
gonna-
magic constants, right?
You can
You
what do
can
you
hide
mean?
the magic numbers in your code, like 1024 or -1 or things of that sort.
For
Code would
what?
normally depend on.
For what reason? Why would you want to hide magic numbers? Like
Because they're,
Secrets?
you know, they're used to indicate certain states inside of the application. And if you never
You know
use-
the guy's always using a 4K buffer, and then the numbers aren't 4K anymore. They're harder to find in the code.
Okay.
So
error
you could
status
actually-
from a
you could-
method, for instance.
Quick
So you-
searches don't reveal the repeated use of the 4K whatever.
Yeah. So you're trying to hide things that normally you would be looking for, essentially. So you're saying you're trying to hide secrets in there, or you're trying to hide known values, known constants.
Idiomatic code,
Yeah.
if I'm trying to figure out where.
Yeah. Well, this is, and that's the
Decisions
point
are made.
of these instruction substitution techniques is, you know, you're trying to defeat tools that rely on signatures, basically, or they'll scan the bytecode, look for sequence of patterns. You know, if you're trying to identify where, you know, an RSA function is implemented, you know, you can look for a sequence of bytes. If you can go in there and you can add things like, you know, replace that add 3 with add 5, subtract 2, then, you know, it's going to break those sequence patterns. Makes sense?
Slow.
What's that?
Slow it down.
It does. I mean, and that's the cost of security.
Well, isn't that the idea? I mean, the whole idea behind doing this to your code is essentially to make it more time-consuming and more expensive to reverse engineer it than to create it from scratch.
No, I mean it would slow down performance.
Running
Of the actual running code.
Oh.
Yeah,
JIT
the-
compiler would take care of the +5 -3 in public.
Yeah, but then your decompiler can run it through the chip compiler and run it back.
Optimize it that way. Both points are valid. Yeah, it's gonna, you know, likely what's gonna happen when you add these security things, your program's gonna slow down a little bit. Actually, there are some cases where these security tools can actually optimize your code, again, better than what the linkers and compilers do. So you'll actually see some performance increase. For example, they can remove dead code. They can look to see, are there areas of code that just are never executed? There's no control flow paths that go through it, so they'll remove that code. So you'll see some speed up, but in general, you add security, you're going to slow things down. But the other point was, you're trying to add so much that as an adversary that's trying to, either reverse engineer your code or do some tampering, that they're going to look at, and they're going to spend so much time on it that they're going to give up. And hacking is a business essentially. I mean, it's an ROI. So if you can't spend infinite time on these things, you got to move on and go attack the low-hanging fruit. So, and none of these things are foolproof. I mean, and by no means am I trying to tell you that you apply these things and your code's so safe and you don't have to worry about it. I mean, this is software, right? I mean, at the end of the day, all software systems can be broken, right? With enough time, enough energy, enough financial motivation, they can all be broken. And it's an arms race, right? For every technique that a software company like ours comes up with, there's an adversary out there who's coming up with a way to break it. And so it's, this is the arms race. Again, I'm probably telling you things that you already know. Metadata renaming. In this case, those variable names that you use, like password or secret, things like that, that's all stored in the metadata. So when I'm looking at your program trying to reverse engineer it, I'm doing keyword searches for like passwords or strings that would tip me off to something secret, something you're trying to hide. So one of the things that you can do is you can either, when you're programming, you can use obfuscated names, but that's clunky, right? Because the whole point of software development is to make it easy to reuse, and so you can use an automated tool that will go in there and basically rename all that metadata for you. Right at that point, we're ready to release code. What you can also do is you can, when you do have a crash out in the field, we're talking about how debugging's more difficult when you do these things. There are software tools that will basically, create or save information about that renaming transformation. So when you get a stack dump back, you can, although you're looking at obfuscated names or obfuscated strings, you can do that transformation back. So you can, it makes it readable for you, the developer. Just don't ship that log file with terrible joke. String encryption. This was I was looking at a software application the other day, and it was you have to enter this like string to basically get into the program, and the string was hello, and I decompiled the program and just saw where the hello was hard coded inside there. You could brute force it, things like that, but I just decided to go look at the string. The point is, if you have to hard code strings into your program, at least try to encrypt them. And again, you can do this at a source code level, but as developers, we all know that the PM's pushing us to release code on time. Encrypting is not always the easiest thing to implement. So again, an automated tool can actually go in there and they can encrypt all these strings for you. They can decrypt them either in real time, like as the strings are needed, or they can just do a whole shot decryption the first time the program loads up.
And so the decryption is done. I mean, that would be part of what you ship. I mean, this actually happens at runtime?
Yeah, so
Okay.
this would be code that's actually added to your jar files. Essentially, adding new code to what you've already created.
So it's just other classes that are in there?
So there are classes there.
Okay.
Yeah.
And so as long as they can't decompile those, right?
Yeah, those have to be protected. I mean, there's probably going to be a key that's in there that's used for the decryption. Sure.
Okay.
Yep. Good point. Again, we're just raising the bar a little bit. We're trying to make it a little bit harder for them to do certain things. And then there's anti-debug techniques too. So these make development just a nightmare. But essentially, you can there's software tricks you can use to make software unable to run inside debuggers. You can add, for example, Windows has an API called is debugger present. You can call a function like that, you can check to see is my application being debugged. You can look for debug registers, hardware registers. When you're debugging code, you're actually changing code. You're putting software breakpoints inside there, and those breakpoints are actually modifying code. So if you can go and you can kind of detect code, or at least do an integrity verification of code, you can see those breakpoints in there. This is, an adversary's favorite tool is a debugger. So if you can prevent them from using this, or at least make it that much more difficult, then you're raising the bar that much higher.
Then you wouldn't be able to use the debugger as a developer, or you still could?
This is the challenge. Yeah, I mean, in some cases, yeah, you won't be able to do that debugging yourself.
Wow.
It just depends on which technique you use, I guess. Just our company, we've got something called authorized debugging. So, when these debug guards, anti-debug guards, are running, they'll actually check to see if you have special permission to do debugging. And only if you have that special permission will you be allowed to do debugging. Otherwise, they'll take an action, like either crash the program or phone home or do something like that.
The special permissions, like a certificate or something like that on your machine?
Yeah, like
Okay.
a license file.
That puts me in the question of maybe the anti-debug stuff and the string encryption. The string encryption seems like it presupposes that you have got some anti-debugging. Otherwise, what's the point of the string encryption? Wouldn't the normal attack, your example is searching with that low string, wouldn't you just normally try to just intercept the app at the point it's about to check the string, and no matter how it's encrypted, you just step through and see the decrypted string, and it's like, what's the point of going all the work with the string encryption, which is a huge operation, right? Just
Right.
a trivial solution.
Right. So the question is, why not just set a breakpoint while the program's running, and then go and look at memory and find the string after it's been encrypted? That's great if you know where to put the breakpoint.
That's a lot harder, right? Rather than just searching through this source code
Is
for a
that
while.
really actually
Prevent
that
the
hard?
static analysis by
Yeah.
Static, but
Prevents the static analysis.
So is it usually it's hard to approach it. You would think, most apps is like an initialization sequences when all of this stuff's going to happen, all the sequencing going to get processed. Wouldn't seem like it's that hard to debug it and try and step through that. If you spend a day, it's not a lot of fun, right? But it seems
Not a
like
lot
I've
of
seen
fun.
most of those secrets go by.
Yep.
Depends on how
So
much code there is.
How we get to start around, right? But
you certainly can. You certainly can. Try to find the point in time when you think that data is sitting in memory, and you can try to put a breakpoint there. You can dump memory, or you can just go inspect memory. That's why there are these anti-debug guards, because you're in order to set those breakpoints and do that memory dumping, you're using a debugger. So in combination, these are powerful things.
Or a FireWire device.
What's that?
I said or an external FireWire device.
In what case?
FireWire.
Yes. For debugging.
Yeah, FireWire allows the device to use direct memory access,
Okay.
which is
Okay.
why a bunch of the new operating systems disable it. But it's very handy for writing a remote debugger. For like somebody wrote a Linux kernel debugger that used that. You didn't have to breakpoint the kernel. You could just keep scanning memories and like that.
Gotcha. All right. So
And the machine couldn't really stop you.
So you're kind of you're subverting the operating system, and you're going directly to memory,
Yeah, you're talking straight to the
straight to memory. Okay. Either way, you get to memory. You can see these things. There are other techniques you can use. For example, when you do the encryption, as soon as you use the value, or as soon as whatever you've encrypted, as soon as you've used it, just re-encrypt it. Don't just leave it in memory. Decrypt it.
So only unencrypt it while you're using it.
While you're using it.
Basically the shortest amount of
Create
time.
that small window of time.
Yep.
Decrypt, use, and then encrypt. So if you don't memory, again, you're going to have to find the exact point in time when that value is sitting there.
And you're going to hit performance with this too, right? Of course. Well, I mean,
Are you writing no? It's true. This comes at a cost.
Yeah, performance can be really important with some things, right?
Right over.
Right.
That's what you're doing. If you're just
Yeah.
trying to protect the startup sequence, that doesn't matter quite so
But
much.
every time you use a variable, right, depending on if it's used
Could be
just
a
during
problem.
startup, but if it's used in, and it depends on if you're encrypting every string, right? There is.
Yep, no, those are very good points. And so, when you're, if you are at a point where you're evaluating kind of solutions that do this, one of the things you want to look for is a solution that allows you to go in and basically select which data values do you want to encrypt, decrypt, and rather than just a wholesale. All right, I want everything, because some things like there's just some strings that you don't care if somebody
error
sees.
messages.
Yeah, error messages, for example.
Yeah.
Well, there's a
Display name.
There's a silver lining to that. If it runs too slow on the client when it's obfuscated, you should move it back to the server and you don't have a problem.
Yeah, if users didn't use
Problem
software, there'd be no bugs.
Can't hear you back here, guys.
Your code
I
is
said
slowing down,
if
no
it
one
runs
knows
too
to steal
slow
it.
on the client, you move it back to the server where it belongs, and then there's no problem.
We were just saying everyone writes bug-free code. Just moving on here in this interest of time. Anti-tamper, integrity verification. So this would be like a checksum or a digital signature of your code. Once you've compiled, once you create that bytecode, create a hash value of that code, and then before the program is executed, recompute. Have some code inside there, like a startup routine, that actually recomputes that hash value and compares it to the one that was created, before you shipped your code. And only if those values match, then load the program. Otherwise, don't load.
I mean, if the jars are signed like that, you're pretty safe, right?
For every there's always ways around this. But yeah, I mean, you can either have, you can have the JRE enforce this. You can write this logic yourself, to kind of have your own integrity verification solution that at least, there may not be a scripted exploit out there for. You're forcing them to kind of defeat your solution. And you also don't need, like, a digital signature is only going to check when the program first loads. So, if you are able to attach a debugger and you go in there and you're not just looking for data values anymore, but you're actually looking for code and you're making code changes, then, if you do your checksum right up front, then the program loads into memory, and then you go and you change that code in memory, well, you're not going to be able to detect that, right, with this approach.
But what are you talking about? You go and change the code after it's running in memory?
Yeah.
Okay, I guess that's a little confusing, right? I mean, obviously, if you take the code, right, and you change it before it's loaded, given to the person or whatever, right? That makes sense. But
Yep.
you're saying once it's already running, then you change the code?
An example of this is like similar with encryption wrappers.
What's that?
Like an encryption wrapper.
Uh-huh.
Like an encryption wrapper, it's so your code's completely encapsulated, encrypted. The first thing it has to do is actually decrypt that code so you can actually run it to the JRE. In a lot of cases, that code is decrypted to like a location on disk.
Oh, okay.
Go in there, so if you do your checksum too early,
Okay.
the point is if you do it too early, there's still a point in time you can go and you can change that code.
Okay.
So, if you're looking at, if you want to prevent tampering, think not just about checking at startup, but also doing periodic checks while your code is actually executing.
So we were talking a moment ago about encrypted jar files.
Yeah.
And if we do it the right way, use digital signatures and all, there's issues around that in terms of, like, people can break into that. Is that
Yeah.
is it still a big problem?
I mean, there's no silver bullet, unfortunately. So, there are ways to circumvent encryption wrappers. Just Google search for it. You'll find kind of how-to step-by-steps that actually show you how to decrypt. I'll show you. So, I don't want to jump the gun. I do have a slide on that encryption, so let me address that in a minute.
Okay,
And then, well, actually, it's a good segue. So, encryption.
good.
Look at that.
How about that?
So this is the problem I was just describing. These class loaders, they extend the JVM. Usually they're re-implementing two methods, define class or find class. And essentially what they're doing is, when you compile and you link and you get your jar file, you're applying an encryption wrapper around it, and you're putting a little stub there that's basically the first piece of code that's executed or run. That stub code executes, and what it does is it decrypts everything. The problem is, though, because there's basically only 2 points that you can go and you can have this stub code execute. If you're able to actually break, you're talking about finding good places to set breakpoints. set breakpoints here, because what you can do essentially is you can go in and you can basically add code that will say, after you've decrypted, just write the full contents to disk, write the decrypted contents to disk. And then just go in and load that decrypted stuff into your decompiler, and now you're able to actually decompile this code. I mean, these are good. These are good solutions to stop. A script kiddie. Just someone that is just kind of likes to toy around with hacking. But for a real adversary, this isn't going to maybe a couple days for them to work past this. Does that answer your question?
Kind of, yeah.
Okay.
Yeah.
Okay.
Just kind of what I looked at through from Sun, sort of said it's a little bit more sophisticated than that.
Yeah.
If you also sign the manifest, and I mean, there's the quick way to do it and the right way to do it. And if you followed the right way, they kind of indicated that it was fairly secure.
That's
So signing is, I'm not specifically just talking about this technique of encryption.
the signing on the jar file stops me from modifying classes and giving them to you and you running them without realizing that you're running modified classes.
Yes.
Yeah.
If you want me to modify the classes for you, if that was the intent, then you can change your JRE settings so that you would trust what I gave you just as much as you trusted the stuff you got from E-Trade or wherever.
Yes.
The thing is when I have done it without your consent, it stops that.
Does it?
But if the end user is the one who wants to tamper with the data, you can't stop them with signed jar files.
Yeah.
Yeah.
They can
You
just
can
accept
only
them.
stop a
There's
man in
ways.
the middle from doing it.
That's good.
So that's a really good. The point is essentially, when you're running these modules, if your intent is to try to trick somebody into running something, there are mechanisms in place that the JRE tries to enforce. But if your goal is to basically attack the code yourself for your own malicious purpose, you have total control of the machine. You have total control of the code. It's what we call malicious host. Essentially, your root access. You can do whatever you want on that thing. So you want to turn off security controls in the JRE, turn them off. You're essentially in control of everything that happens in there, and that's a really good point.
Yeah, I can sign it with a different key and you can just add it to your trusted list, for instance.
Just last couple slides here. Specifically, the technology that we have is it's called Guarded. It's a product called Guarded for Java. This is newish technology for us. We got our start really with protecting C code, Fortran code, Ada code. We've now kind of moved into these managed languages. We've got a Guarded for .NET. We have a Guarded for Java. So you see renaming in there. Again, I highlighted that in an earlier slide. We do our class encryption in a little bit different way. We do an encryption using an agent. Essentially, what we're trying to do is we're trying to do the decryption at a stage that is early enough where somebody can't just go inside and set breakpoints and do the decryption. The earlier you do it, the earlier you're able to implement these things, the better off you are. And so our solution leverages an agent. If you're familiar with an agent, it's typically something that a parameter that you have to pass to the JRE. An agent's like a separate jar file. And within that agent is really the routines that say how to do the decryption. Well, the advantage of putting it in there is that we have total control over how we obfuscate and protect that. So, somebody mentioned before, well, why not just go and decompile that encrypted code and find the secrets? Well, with our agent, it's easier for us to go and protect that code and secure it. Again, this isn't bulletproof. I'm not saying a lot of smart people in the audience, but again, we're trying to raise the bar here.
And what protects the agent?
Yeah. Well, we protect the agent with Guarded, obviously.
As another agent.
Turtle will bring
Yeah.
it down.
Yeah.
It's turtle all the way down.
So agents protecting agents protecting agents, which sounds funny, but one of the reasons that our solutions are so effective is we deploy defense in depth solution. So literally for all these things that we put inside to protect your code, when you're using our tool, you can actually have control over how many layers you want it to go up. So essentially, if you think about all of these guards protecting your user code, you can essentially use all these guards to protect guards. And you can use another set of guards to protect other guards. So you're creating these layers of protection. Again, as an adversary looking at this, they're going, all right, well, I got to go defeat this, and now I got to go defeat this, and this, and this, and this. And you add into all this with some of the guards that actually execute at runtime, you can actually randomize them, so they're not executing every time the application is running. So it's kind of like a moving maze in that sense. As an adversary, you run it once, and you're like, okay, I see these guards, I've disabled them. Now I run it again, I got a whole new set of behavior, and they're all interconnected in that.
So when you're talking about layering, you're just talking about which ones of these you're doing, right? You're not talking about doing them multiple times or anything, right?
Well, that's an option as
I mean, like layering, you mean you do renaming guard and obfuscation guard or something, right? Is that what you mean? Do you have one layered on top of the other? Is that right? Or?
you can apply obfuscation. So I give an example of instruction substitution. Maybe not the best example, but that's one layer of obfuscation. You could actually go back and re-obfuscate that obfuscated.
Oh, okay, I get it.
Again, you add layers and you're going to affect performance. I'll just say it before you say it. You're going to affect performance, but in some cases, maybe the code you're trying to protect isn't your performance critical code, and that's another important point is when you're looking at solutions, find one that allows you to exclude that performance critical code. I mean, if it's not security sensitive, it's just performance sensitive, don't even touch it. You've optimized that code. You probably spent a lot of time optimizing it. Don't let the security tools go touch it.
And when you said that you can make it so it randomly does it, so does this like run on the server where it's serving up the jar files or something, or?
All of these guards are actually, so our solutions, our technology is applied post-link, post-compilation. Well, post-compilation. Rather than at a source code level, we'll actually go and we'll add these things into
That's part of like the build process?
It's part of the build process.
Okay.
Like the last step in the build
okay, and so
process.
for a defined release, it would be one thing, right? It would have a certain number of guards on it for a defined release, right?
Absolutely.
Yeah, okay.
It'd have a certain number of guards, and then there's parameters within each guard that say execute 50% of the time. Like, let me try to give a good example here. Would that be? For example, string encryption. We mentioned how you could basically just do a decrypt and just leave it in memory, or you can do a decrypt and then a re-encrypt. That'd be a parameter. So you're just changing the behavior of this based on runtime. Again, if you've ever tried to debug code that's kind of changing like this, it's not an easy thing to do. We've got integration into the Eclipse IBM RAD toolkit, and we've got some flyers, handouts back there. Please feel free to ask either myself or George any questions. I really appreciate you guys sitting through this. And do you have any other questions for me? Go ahead.
So the last time I used a code obfuscator, it was predominantly to shrink a cell phone app. And one of the things that struck me fairly hard was that if your app uses a lot of the JDK, there's a substantial fraction of your application that cannot be obfuscated easily. You guys do all of the string concepts. You can't change the name of the classes in Java util, for instance.
Yeah.
Do you guys do anything that goes across into the JRE? Do you like duplicate code or things like that?
Not at this point. So the question is,
The smaller the app, the more it's relying on The built-in libraries.
It's the built-in libraries, right?
It'll be hard because you wouldn't know what version it's going to be of the JRE.
Yeah.
right?
Well, but if you're
Yeah.
relying largely on the JRE to do some of your stuff for you, then it's pretty obvious what your code is doing, even if it's
yeah,
obfuscated.
yeah.
Because it keeps calling into
Different
the
libraries,
subcode.
external libraries, yeah. So we haven't at this point, I mean, our protections are basically focused on the jar files that you produce as a developer, not as any external libraries or JRE that's produced by Sun or anybody else that's got a custom JVM. The primary reason we're doing that at this point is just because our customers have told us we don't want to have to ship custom JREs. We don't want to, we don't want to. I think if a customer said they're willing to do that, I think our technology could be applied in that way. But up to this point, people seem to like the fact that you can just ship your code and it runs on any JVM.
Yeah.
Does that make sense? Sure. Any other questions?
The bus loader encryption,
Yeah.
where do you store the key, and how do you prevent the moment that the bytecode's decrypted from someone using a modified JRE to stream the Java bytecodes out?
Yeah. So the question is, where do you store the encrypted key when you're using any kind of class encryption or encryption? That's a good question. Specifically, you mean for our product? Where do we store the key? So,
Somewhere in that jar is that key. We can just find it.
yeah.
Keep
Can't
on
tell you
down.
where it's at. No, it's so. I mean that is that's an attack vector. The way that we've kind of overcome this problem is we've got another solution technology product called Transform It, which is a key hiding solution. Essentially, it allows us to do RSA and ECC or asymmetric decryption and encryption. It's called white box cryptography. So you can do these decryption routines, and using certain exponentiation properties of RSA, you can do these things like decryption without ever actually having to store that key or having it to be exposed in memory at any certain time. George, do we have a flyer on Transform It? We do. Okay, so see me afterwards. I can go into more detail with you when I'm not staring at a camera.
I've read a little bit about white box. Yeah, I know what you're talking about.
Okay, so the term's white box cryptography. It's a key hiding solution. White box cryptography is kind of the academic name for it. Our product's called Transform It. But yeah, I mean, if you find yourself needing to hide keys, you might be interested in this a solution like this. But so anyway, the point is we use that inside our agent files to hide these keys. Again, just raising the bar.
And that's available as a standalone product?
That's available as a standalone product.
And then the follow-up question was, once the Java bytecodes are decrypted,
Yeah.
just what to prevent the modified JRE from streaming them out and saving off the decrypted class?
Yeah. So that's the challenge with most of the class encryption loaders, out there, is that you can do that. You can basically rewrite code in these defined class methods. Using the agent, we're forcing adversaries to attack it at a different level. I don't know how much else I can say about it right now, but just come talk to me afterwards, I guess, and I can be more than happy to explain it. Any other questions?
So do you guys sell tools to break into software too, or just?
We sell it. That's good.
It's a market opportunity.
You think there's a market? Yeah, there definitely is a market for it.
Those are in the alley behind.
Yeah.
The building.
Oh, okay. That's the alternative business plan.
Yeah.
All right.
Thank you.
So unless anybody else has questions, thanks for coming. Looks like we're done a little early. So if people want to stick around, oh wait, almost forgot. For people who have filled out the forms, I don't know if people want to take 5 minutes to fill out the forms. We'll have a little drawing for the $50 gift cards.
Yeah, $50, yeah.
So if folks want to take some time, fill them out.
Giving away money.
Giving away money. Yep.
So does anyone not have a form?
Yeah.
Or-